In a main panel, the ground and neutral buses are connected, establishing a common neutral ground bond. However, this configuration is not permissible in a subpanel. The separation of ground and neutral buses in a subpanel is crucial for electrical safety and proper circuit operation. Firstly, subpanels might receive power from multiple sources. This arrangement could lead to conflicting paths for neutral currents if the ground and neutral were bonded together. Separating the buses ensures that neutral currents are confined to the neutral conductor, preventing them from flowing through the ground wire. Secondly, neutral current flow on the ground wire can create safety hazards. If neutral currents flow on the ground wire, it can cause overvoltages on equipment grounded through metal conduits or other grounding paths. This poses a risk of electric shock and equipment damage. The 2-inch rigid conduit connecting the meter base and the subpanel does not make them a single electrical unit. While the conduit provides a physical connection, it is not considered a reliable conductor for electrical current for several reasons. Firstly, conduit is typically made of galvanized steel, which has a lower conductivity compared to copper or aluminum wire. This means that conduit is not as efficient at carrying electrical current as dedicated conductors. Secondly, conduit joints and fittings introduce resistance and impedance into the circuit. These factors impede the flow of electrical current through the conduit. Thirdly, the conduit is subject to corrosion or other deterioration over time, which can further affect its ability to conduct current reliably. Therefore, even with the conduit connection, the panel on the other side of the block wall is still treated as a separate subpanel. This designation requires adherence to the grounding and neutral separation rules. To properly ground the subpanel, you need to install an additional grounding bus. Here is how. Firstly, install the new grounding bus on the side of the panel opposite the existing neutral bus. This separation helps to maintain distinct paths for neutral and ground currents. Secondly, connect the grounding bus to the panel enclosure using the provided bonding screw or strap. This connection ensures that the grounding bus is effectively bonded to the metal enclosure of the subpanel. Thirdly, connect the grounding wires from the subpanel's branch circuits to the new grounding bus. This establishes a dedicated grounding path for each circuit. Fourthly, do not connect any neutral wires to the grounding bus. The neutral wires should only be connected to the neutral bus, maintaining the separation between neutral and ground. By following these steps, you create a safe and compliant grounding system for the subpanel, preventing neutral currents from flowing on the ground wire and minimizing the risk of electrical hazards. Understanding the difference between grounding and neutral conductors is fundamental to electrical safety. Grounding conductors provide a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protection devices such as circuit breakers. Neutral conductors, on the other hand, carry the normal and balanced current from the load back to the source. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding electrical systems. These requirements are designed to ensure electrical safety and prevent hazards such as electric shock and fire. Article 250 of the NEC covers grounding and bonding. This article specifies the requirements for grounding electrode systems, equipment grounding conductors, and bonding of metal enclosures. NEC Section 250.24 FIV addresses the grounding of electrical services and the neutral ground bond. NEC Section 250.32 covers grounding requirements for separate buildings or structures, which is relevant to subpanels. When installing a subpanel, it is crucial to follow the NEC requirements for grounding and bonding. This includes properly sizing the grounding electrode conductor, connecting it to a suitable grounding electrode system, and ensuring that all metal enclosures are bonded together. In addition to the NEC, local electrical codes and regulations may also apply. It is important to consult with a qualified electrician or electrical inspector to ensure that your electrical installation complies with all applicable codes and regulations. When selecting electrical equipment, such as panels and circuit breakers, it is essential to choose products that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or UL. UL listing indicates that the equipment has been tested and meets established safety standards. When working with electrical systems, it is always important to follow safe work practices. This includes de-energizing circuits before working on them, using appropriate personal protective equipment, such as gloves and safety glasses, and following lockout-tagout procedures. Regular inspection and maintenance of electrical systems are essential to ensure their continued safety and reliability. This includes checking for loose connections, damaged wiring, and corroded components. Any identified problem should be addressed promptly by a qualified electrician. The proper installation and maintenance of grounding and bonding systems are critical for electrical safety. By following the NEC requirements and safe work practices, you can minimize the risk of electrical hazards and protect yourself and others from electric shock and fire. The size of the grounding electrode conductor is determined by NEC Table 250.66, based on the size of the ungrounded service entrance conductors. The grounding electrode conductor connects the neutral bus in the service equipment to the grounding electrode system. Common grounding electrodes include ground rods, metal underground water pipes, and concrete encased electrodes, also known as UFRs. The equipment grounding conductor, or EG, provides a low impedance path for fault current to return to the source. The EGC is typically a copper or aluminum wire that is run with the circuit conductors. The size of the equipment grounding conductor is determined by NEC Table 250.122, based on the rating of the overcurrent protection device. Bonding is the process of connecting metal enclosures and other non-current carrying metal parts together to create an electrically conductive path. Bonding helps to ensure that all metal parts are at the same electrical potential, minimizing the risk of electric shock. NEC Section 250.92 covers bonding requirements for service equipment. NEC Section 250.96 covers bonding requirements for other metal enclosures. When installing a subpanel, it is important to isolate the neutral conductor from the equipment grounding conductor. This is typically accomplished by using an insulated neutral bus and a separate equipment grounding bus. The equipment grounding bus is connected to the metal enclosure of the subpanel and to the equipment grounding conductors of the branch circuits. The neutral bus is connected to the neutral conductor of the feeder circuit. Surge protective devices, or SPDs, are used to protect electrical equipment from voltage surges. SPD are typically installed at the service entrance and at subpanels. NEC Section 285 covers surge protective devices. When installing an SPD, it is important to follow the manufacturer's instructions and the NEC requirements. The SPD should be properly grounded and bonded to ensure effective surge protection. Ground fault circuit interrupters, or GFCIs, are used to protect people from electric shock. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. NEC Section 210.8 covers GFCI protection requirements. When installing a GFCI, it is important to follow the manufacturer's instructions and the NEC requirements. The GFCI should be tested regularly to ensure that it is functioning properly. Arc fault circuit interrupters, or AFSIs, are used to protect against electrical fires. AFSIs are required in certain locations, such as bedrooms. NEC Section 210.12 covers AFSI protection requirements. When installing an AFSI, it is important to follow the manufacturer's instructions and the NEC requirements. The AFSI should be tested regularly to ensure that it is functioning properly. Electrical panels should be properly labeled to identify the circuits they serve. This helps to prevent confusion and makes it easier to troubleshoot electrical problems. NEC Section 408.4 covers panel board labeling requirements. The labeling should be clear, accurate, and durable. Overcurrent protection devices such as circuit breakers and fuses are used to protect electrical circuits from overloads and short circuits. It is important to select the correct size overcurrent protection device for each circuit. NEC Section 240.4 covers overcurrent protection requirements. The overcurrent protection device should be properly labeled to indicate its ampacity. Electrical wiring should be installed in accordance with the NEC requirements. This includes using the correct type and size of wire for each circuit, properly supporting and securing the wiring, and protecting the wiring from physical damage. NEC Chapter 3 covers wiring methods and materials. Electrical connections should be made using approved methods and materials. This includes using properly sized wire connectors, making sure the connections are tight, and insulating the connections properly. NEC Section 110.14 covers electrical connection requirements. Electrical equipment should be installed in a neat and workmanlike manner. This means that the equipment should be installed level, plumb, and square, and that the wiring should be neatly arranged and properly supported. NEC Section 110.12 covers workmanship requirements. Before energizing an electrical installation, it is important to inspect it thoroughly to ensure that it is safe and compliant with the NEC requirements. This includes checking for loose connections, damaged wiring, and improper grounding. Any identified problems should be corrected before energizing the installation. Regular maintenance of electrical systems is essential to ensure their continued safety and reliability. This includes inspecting the equipment, testing the overcurrent protection devices, and cleaning the equipment. A qualified electrician should perform maintenance on electrical systems. When working on electrical systems, it is important to follow safe work practices. This includes energizing circuits before working on them, using appropriate personal protective equipment, and following lockout-tagout procedures. Only qualified electricians should work on electrical systems. The information provided in this narration is for general informational purposes only and should not be considered as professional electrical advice. Always consult with a qualified electrician for any electrical work or projects. Incorrectly working on an electrical system could result in injury or death. It is important to always follow all electrical codes and safety practices when working with electricity. Remember, electrical safety is paramount. Always prioritize safety when working with electrical systems.